Hi everyone, in the previous chapter we learned about how we can define generics and how we can use them with functions. And in this chapter we are going to learn about specifically how we can use generics with structs and enums. So let's start with generics and structs. So far we used this generics many times with enums, actually using options and result as we talked before. Now let's see how we can use with structs, which is very similar. First I'm going to create a struct and I'm going to call it container. It's going to have a generic type t, and in this container I'm going to have a value type t. And in my main I'm going to create an integer container. This will be a container, and inside this I'm going to have a value which is 42. I love 42. Now let's create another one. Let's say str container, and this will be another container with the value of, let's say, sign. Now we have two different containers with totally two different values. One is i32 and the other one is a string reference. If I go here and say int container that value, and here if I say str container that value, and if we say cargo build, and you know what's coming, cargo run, you can see we got 42 and Simon. So we had our generic type t and we have the value t. Whatever we put here as the t, we got here in the value. So we put i32 which is 42 and our value was i32 which is 42. And I put Simon here and it's a string slice, and for that value we are also going to have a string slice. And then I print out the value here for both cases and we got the separate results. And as you can see, this way we can utilize this generics using structs. And now let's see how we can utilize this generics using enums. So let's create an enum here. I'm going to call it magical result, which is the same with the result actually, but the name has magical, so it's better. And inside this I'm going to have success that has the t, and also I'm going to have failure which will have e. Alright, so it's like the result enum. We have two generic types here, t and e. T for the success, e for the failure. Whatever we pass on t, then we are going to have it in the success situation, and whatever we pass on e, we are going to have it in the failure situation. So here let's say let success result, and for the type let's say magical result, and it's going to be i32 and string, and for that I'm going to say magical result, we want success, and you know it, we got 42 here. For the other one I'm going to say failure result, and the type will be the same, magical result, i32 and string, and it's going to be magical result failure, and I'm going to say, well, it failed, and we are going to say to string because our type is string. And underneath I'm going to have two different match statements, but I need something to match with, obviously. I'm going to say success result for that one, and inside this we have two different cases. Let's create them. For this we are going to have value, and if this is our case, then we are going to say println we got success, and then we are going to say value. For this one we will have really similar thing, so I'm going to copy and paste it in here. We are going to say we got failure. Let's make this value 2, and let's check this out. So we have our success result to match here, and we have two possible cases. The first case is that we have a success in the magical result, and if you look at this magical result success value, and if we look at our magical result, which is magical result success 42, And as you know, this value will be 42. So if you can see, everything is same other than this. So it gets the 42 from here. And once we say we got success as the value, we will have 42. And since the second match arm doesn't meet the condition, we were able to go past it in our first match arm. So I'm going to create another one here. And this will be for the failure one. Let's say failure here. And for the failure one, we are going to have the same match, but it's not going to be executed in the first match arm because our failure result is magical result failure. And this first match arm is magical result success, so we are not going to run this. Then we are going to go to the next one, which is magical result failure. And in this one, we got magical result failure with it failed string. We convert this to a string here with this method. And in the magical result failure, actually we are doing the same thing. We have the same value with this one here. So our value will be it failed. And the expected result is we got failure and we got the value. Let's say cargo run. And as you can see, we got success 42 and we got failure, it failed. Well, two different ways to say the same thing, I guess. Now, let's see how we can use generics with associated types and what are associated types. This time I went ahead and pasted the code here so we can examine and create a test for it. So let's see this code. What we have is a trait and we have a function here, but what's different with this trait is we have an associated type here. And as you can see, we just have the word type fuel, which doesn't indicate anything, so we don't know which type it is. But we know that we are going to use this fuel here as a second parameter in our function. The name of the parameter is fuel, and the value and the type of the fuel will be self fuel. And if we say this fuel is integer, then this is integer. If we say string, then this is string, like the basic ideology of the generics. And we have two different structs. One is electric car and one is gas car. In electric car, we have the battery level, and for the gas car, obviously we have the gas level. We set U32 because we cannot have like minus 40% gas, unfortunately. So let's implement this vehicle for the electric car. First, we set type fuel equals U32. After that point, this will be U32 in our implementation in the electric car, and this will be U32, and that's the whole point. And inside this function, as you can see, we can change the name of this to charge, and it has the same type, and this type will be U32 for our function. And we are increasing our battery level with the charge that we got here as a parameter, and then we are printing out the value. For the gas car, we have the same associated type here, but now we are saying it's F32. And here we are refueling with this function, and the name of this variable here is gas, but we have the same type with the definition in the trait here. But for that one, it's going to be F32 instead of U32. And we are making our calculation here. We are increasing the gas level with this multiplication here. And since our gas is F32, we have no problem. And then we are converting this to an U32 and we are printing out the value. So let's create an example and see how we can utilize this. First, I'm going to say let Honda. I'm saying Honda because I had an Honda Jazz back in Turkey and I really miss it. And it's going to be an electric car, let's say electric car here, and the battery level, let's say it's 42%, like we love this number. Let's say let Ford equals gas car, come on Ford, and we are going to say gas level, and let's say it's 20%. I'm going to say Honda.refuel, and let's fill it till 100%. For that, I need 58. And these should be mutable because we are going to alter the battery level and the gas level with this function. And then I'm going to say Ford.refuel, and here we are going to say 0. Let's say 2. So let's run this and check what happens. As you can see, we got battery charge to 100% and the gas tank filled 40%, obviously since the gas prices are very high. So let's see how this happened. So we have our self.battery level here, and the charge that we provided is 58 and the charge we already have is 42. And we are saying 58 plus 42 here, and the sum is 100, and we are printing out here. Since our fuel was U32, we just passed 42, which is interpreted as U32. But for the gas car, we had F32, so we had to pass a float here. With the 0.2, this gas times 100 becomes 20, and then we are adding this to our current gas level, which was 20 in the beginning. That's why we have 40% at the end. And that's how we can use associated types with traits in correlation with the generics. And that's all for the generics section. Don't forget to use generics in caution because we have trade-offs for the compile time. It takes a little more to compile since we are creating every different function, but the good part is that we don't have to worry about the performance when this runs because we already have the functions. We have nothing to add on during the runtime for the performance. But also don't forget that we are also increasing the binary size after we compiled our code. So these are the trade-offs. Just be aware when you want to use generics. And we are going to use generics in many other places. I'm pretty sure if you checked any Rust code online, you can see generics everywhere, which is a very convenient and useful way. So thank you very much for this chapter. Thank you very much for sticking with me the whole generics. And I'm going to see you on the next one.